Okay, so on this first problem, you got sides of 8 and 9. And the question is, if there's a 38-degree angle between them, you've got formulas that you have learned that would tell you what the area of the triangle is if you were to connect the third side, the red side. And how long is that red side that would be the third side of the triangle if we were to connect them? I'll pause for a second while you use probably 2 different trig formulas to figure this out. Here we go. The area of this thing. Now you could do it with a nice simple formula. Do you remember it, Mr. P? The area formula for this? Excellent. And in this case, that'd be 1/2. What did you pick for A? Okay, times 9 times sine of what? There we go. This one's really straightforward, just following a formula. What did you get for your final answer? I like it. And if this had units, we would have said units squared. Raise your hand if you had that one right. Okay, good. All right, let's move on to the area part. That was the area, sorry. The red part, the red side. Mr. GC in the back, tell me how to do this one. All right, I know the law of cosines. A squared plus B squared minus 2AB sine, nope, cosine. C equals C squared, and then what did you do? 8 squared plus 9 squared minus 2 times 8 times 9 cosine of 38, and that equals C squared. At the end, did you take a square root to get your answer? Excellent. What did you get? You haven't got it yet? All right. I'll try somebody else. Who's actually got the final answer for that one? 5 people? Seriously? All right. What'd you get? 5.6. Raise your hand if you can confirm that. Okay, good. All right. So there's your first 2. They should have been easy. That's R2 level kind of stuff. Any questions on that? All right. Now I want to show you a third way that you could solve this. Now, I actually debated on whether or not to tell you this third way just because it isn't necessary. You can do these problems without this third way. But imagine for a moment that we had a 3, 4, 5 right triangle. The reason I'm going to use a right triangle is because it's so easy to check it with its area with this new formula. First of all, just tell me, what's the area? Area's got to be 6. Why? Base times height divided by 2. Okay, good. So 3 to the 4 is 12 divided by 2 is 6. So we know the area is 6. But let me show you a cool way that would work even if it wasn't a right triangle. And I know you know we got formulas for this, right? Which formula would not work? Law of sines would not work because we don't have any side and angle combos. Like if I knew this was a 35-degree angle and I knew this is 3, then I could, make it work with law of sines because I have a combo like this. But if you don't have that, what do you got to use? Law of cosines. But what? Okay. Good question. In this case, because it's a right triangle, yes. But because it's a right triangle, then if you're going to use that, if it's a right triangle, you just might as well go 3 times 4 divided by 2, right? Okay, so if it's not a right triangle, let's say this looks like it's a right triangle, but it's off a little bit. Okay, the method I'm about to show you would work even if it's not a right triangle. I'm using super simple right triangles because we already can tell what the answer is, and then you'll believe me when this works. Okay, so this next thing relies, this next little formula. Again, some of you are going to say, why are you even teaching me this? Because I could do this problem or one like it without this formula. But it's faster. It's way faster. All right? First thing you got to know is what the perimeter is. What's the perimeter of this thing? 12. Then do you know what a semi-perimeter would be then? What does semi mean? Like a semicircle. It means half of, right? So what's a semi-perimeter of this thing? All right, so we'd add them all up, it's 12, and then we take half of that, and the semi-perimeter is 6. Why do we care? Because this new formula is called Hero's Law, and it is that area of this thing would be the square root of that semi-perimeter times 3 things. But those 3 things are super simple. If it was that simple, it'd be really genius, but it's not quite that simple. But it has an A and a B and a C in it. And it doesn't even need a function. It's kind of cool. It's semi-perimeter minus A, the semi-perimeter minus B, and the semi-perimeter minus C. In this case, my semi-perimeter is 6, so I have S's there. But there could be S's there if you're going to write the general form of this formula. I should probably write that for you. Here's the general form of this formula. If S is the semi-perimeter, area, square root of S, and then S minus the A side, S minus the B side, and S minus the C side. So let's just do it for this problem. You'll see how quick it is. Since our semi-perimeter is 6, let's do 6 minus 5 in here, which will be what? 6 minus 4 in here, which will be what? And 6 minus 3 in there, which will be what? And there we go. Square root of 6 times 1, which is 6, times 2 is 12, times 3 is 36. Square root of 36 is 6. See how it worked? Now, just because I showed you that one case worked, is that a mathematical proof? No, but 9 times out of 10, it's going to work. Okay, and I'm not going to try to prove this to you. It just works. It's kind of cool. So I want you to see, if I had one that was 7, 8, and 9, and I get that's not going to make a right triangle, I'll help you get that. If it's 7, 8, and 9, I'd like you to use Hero's Law, the one I just showed you, and find the area of it. Could you do this with law of cosines to find an angle, and then do 1/2 AB sine C? Yeah, but this new way is pretty cool. Yes, sir. Thank you. 7, 8, and 9. And you could have, I shouldn't have even drawn it for you. You could draw it yourself. 7, 8, 9 triangle. Let's see what the area comes up to. Those of you that are working on your corrections, you might want to pay attention to this. What are you? Corrections are not as important as this new stuff. Later in the hour when I'm doing practice, then I drift back to your test maybe. Okay, Mr. GC. Notice you have a calculator in your hand this time. What'd you get? Okay, tell me how to start. And why is it 6? Yeah, exactly. It's a semi-perimeter. In this case, let's see what the semi-perimeter would be. It'd be 15 plus 9 makes 24. Divided by 2 is 12. Semi-perimeter is 12 this time. Raise your hand if you used a 12 for the semi-perimeter. Okay, good? Keep going. All right, so why don't you use a calculator and go ahead and do that. So I'll do the other part. 12 minus 7 is 5. 12 minus 8 is 4. And 12 minus 9 is 3. You multiply all those things together. Take the square root of them. Anybody verify that number? What was it again, Mr. B? All right. And if I had given you units of like miles, this would be in miles squared because it's an area. That make sense? Do you see how that's quick? All right, the other reason to maybe not even include it was just that it doesn't have any trig in it. You get that? Okay, but I wanted to show it to you because the test that you're going to take on Friday is kind of long. And forcing you to use 2 trig formulas to solve this is going to be kind of cruel when there is a shortcut. And so I thought, you know what, even though I skipped it on the day yesterday, I decided it was worth showing you. Okay, so it's called Hero's Law. Again, it's the area is, for the people that were maybe not writing this down before, square root of S, S minus A, S minus B, and S minus C, all multiplied. Okay, now where does this class get harder? Right now, so far, this is all, like, it's just a formula and stick numbers in, right? So how does it get harder? It gets harder when we give you a real world situation. So I'm going to try to give you a real world situation You have to try to put the trig to it to make it work. All right, let's say that you are playing a game where you're trying to claim the most territory. Okay, kind of like Risk, where you want to take over the board, you know. But in this particular game, I'm going to just simplify it down and not have to describe too much, but you're going to make triangles, okay, and you close in an area with your triangle and you get that area and that's all yours, okay. Let's say that instead of making it really complicated by using bearing, we'll do the problems like that later. We're just going to say you walked 2 miles and then you turned at an angle and you walked 3 miles and then you walked all the way back to the starting place and it was 4 miles. How much area did you just enclose? 2, 3, and 4. If I drew the picture for you, that would take away what makes it hard. Next, this is adding a little bit of trig in that you wouldn't have to be doing at this point. What's the biggest angle in the triangle that you paced off? No. I mean, how many degrees is it? You use trig to figure it out. So answer those 2 questions. How much area did you enclose when you walked 2 miles, 3 miles, and 4 miles? And then what was the biggest angle in that triangle that you made? I'll pause for a second while you give that a try. All right, we're back, and I had 2 kids do these. We'll leave them unnamed. And the Cro-Magnon came out with 2.9, and yeah, it's hard to read, but at least I can see it's a 4.5 semi-perimeter. In the middle it gets a little shaky, so I'm going to clarify this part. 4.5, it doesn't take that long. And then the 4.5 minus the 2, which would be 2.5. And then the 4.5 minus the 4, which would be 0.5. And then the 4.5 minus the 3, which would be 1.5. And you multiply them all out and take the square root, and you get 2.9. Raise your hand if you had that one right. Okay, good. And then the next one is, oh, wow, this is nice handwriting. And this one is the law of what's? Cosines. And it looks like they ended up solving for an angle and it came out to 104. Now, what if you had solved for an angle and you'd gotten like 38? How would you know whether you'd gotten the biggest one or not? Well, 38 wouldn't possibly be the biggest one, right? But what if it was something like 70? Can that be the biggest angle in a triangle? Yeah, if it's not a right triangle, it might be. There might be 70, might be the biggest angle. How can you tell? Yes, sir. Mr. L. If it's smaller than 60, it can't be the biggest one. I would agree with that. But what if it's 70? Does it have to be the biggest one if it's 70? All right. Because you could have 70 and 70, which would be like 140. And then the other one would be like 40. So you can't do it that way. How did you know which one to use? You're the one who did it. All right. If you choose this to be your largest side, then it has to go with that angle, and you'll naturally be getting the largest angle. Does that make sense? Okay, good. All right, so, and that one came out to be, again, 100 and some, 104.48, very nice, degrees. Okay, now let's pause for a moment. We're going to get some homework graded. So we're back, and here is another tough problem. Okay, it's not incredibly hard, but it's a word problem. But I've actually drawn the picture for you. I'm going to explain it a little bit. We've got this tower here, and I didn't say how high the tower was, but we walked directly away from the tower for 6 miles, heading due east. We walked out to this spot I'll call A. And then we took a reading back looking up at the tower, and after walking 6 miles away from it, it was a 12-degree angle that we had to look at to see the top of the tower. Now we're not going to add in our height and make it really complicated. We're just going to say from the ground, the angle of elevation would be 12 degrees right there. That's right here. Okay. Then we turned and walked back to this spot B, and the angle we formed with our original path was 25 degrees. So I don't know if you can tell, but this triangle right here is on the ground. It's all on the ground. But then my question is, once you are at B, the question is, what angle would you have if you made a sighting right there to the top of the tower? And then if this was that game where if you walked around the area, you owned it, then how much area did he enclose as he walked back to the tower? Any questions about the picture? Yes, sir.
Okay, so the angle you walk through is 25 degrees, so you turn 25 degrees at A and walk.
We're keeping it simple. This angle that you made on the ground between this path and this path is 25 degrees. Yes. This angle is 12 degrees right here. That's looking up to the tower. That's 12 degrees. Yes, sir.
We're trying to find the angle, the area of the triangle on the ground.
Yes, and the angle from B, if you were to look to the top of the tower, what would that angle be? All right, so it's a hard problem. By the way, sometimes the answer is no solution. I'm not saying that that's the case here. But if I gave you, for instance, a triangle that had sides of 12, 13, and 400, do you get, like, yeah, you can say that triangle all you want, but it can't actually exist. Sides of 12, 13, and 400. So my point is, you can make up situations that can't exist in the real world. I'm not saying this is one of those. I'm just asking you to consider that sometimes the right answer is no solution. You just have to prove it. What I won't accept is kid can't figure it out, writes no solution at the bottom of the page. That's not a no solution proof. You got to show me, oh, this should have worked out to this, and it's coming out to a negative height or something, and therefore no solution. All right, pausing for a moment while you give that a shot. Okay, so here we go. Was it possible? I think so. Okay, good. Let's do one thing at a time. Thank you very much. And tell me, what did you figure out for the height of the tower? Did you figure out the height of the tower?
Yes.
That seemed important. All right, what did you get?
Well, I got the height of the tower.
What is it? 1.28 miles? All right, that'd be a tall tower. But that's okay. So now what? Yes, sir? Now we're answering this question. So, all right. So now what do we do? Yes, sir.
You have to use angle A in the flat triangle. You get B to basically off.
So you wanted to get this distance right here, the red line. All right, good. So how do you get that line that goes, how far it is from B to the tower? Well, it's a triangle. Is it a right triangle? Exactly. If this is east and this is south, that has to be a right angle. Good. We got a right angle. We got a side. We got an angle. You can figure out anything using trig. So we would use probably tangent, right?
Yep,
Tangent to 25 is equal to opposite. Let's call it z. I like that. Over 6. Solve it for me. What'd you get? And that must be miles also. So you're about 2.8 miles away here. Now we've got two sides, 1.28 and 2.8. Can't you get an angle from that? If you got two sides, you can get an angle. Did you notice we didn't even need to use any of the new stuff yet? Okay, good. All right. Now, if this is a right triangle, it even works really nice because that's 6 and that's 2.8 and I can figure out this with the quadratic formula, do I have to find that last side? No, don't have to. Because if I wanted to, I can find this area super easy because, again, it's just base times height divided by 2 because it was a right triangle. Did you get how this would be more challenging if that wasn't a right triangle? All right. Okay, so what if they said from the tower he headed directly east, but then for the other person, there was 2 people walking away from the tower. One of them was heading directly east. The other was heading at a bearing of south 20 degrees west. Here's south. 20 degrees west would be like that maybe. Okay, now all of a sudden the triangle that's on the ground isn't a right triangle anymore. But we give you enough information to solve it. What do you need anyway? Do you need an angle? What if I give you all the sides? Can't you figure out angles? Okay, so do you need angles? No. What if I give you all the angles? Can you figure out the side lengths? No. You'd have to have at least how many side lengths? 1 side length. If I gave you enough angles, you could figure it out. All right. Let's just review that last law that I have, our new one that I just told you, Heron's, or it's actually, technically it is Heron's, but don't pronounce the N, and you've got hero. H-E-R-O-N turns into H-E-R-O. Anyway, Hero's law, the one with the semi-perimeter, let's just use that one last time in the context of a real-world situation. All right? So people start in the middle of the lawn to play this game, and then they have a 8-foot rope. They're each holding one end of an 8-foot rope. One heads at 27 degrees true, and the other one heads at, oh, by the way, and that person that walks at 27 degrees true, they go for 5 feet. They go and, oh, and the other person heads at directly south. Yep. The first person carrying this 8-foot piece of rope, he's got one end of it. He walks for 5 feet. Okay. The other person heads an unknown distance south. Straight south. 27 true. Do you have a triangle that's been set up? Do you know 2 of the sides of your triangle? Yes, you do. All right. Your job is to complete that question and figure out everything, all the angles, all the sides. And next, figure out the other problems that we skipped from the homework before. Go back and do them now. That's your only assignment for tonight. Enjoy that it's small and get it done. Have a great day.